video, we will revise all types of gravitation numericals class 9. So get ready with your notebook and a pen and let's start. Our first question is, a ball is thrown vertically upwards and rises to a height of 10 meter. Calculate the velocity with which the object was thrown upwards and the time taken by the object to reach the highest point. Now we know when an object is thrown vertically upward with a certain velocity, a negative gravitational acceleration acts on it and the velocity becomes zero at the highest point. So here V is 0, S that is highest distance is 10 meter and acceleration due to gravity is minus 9.8 meter per second square. To calculate the initial velocity with which the ball was thrown upward, we will be using the third formula of motion, that is v square is equal to u square plus 2as. Substitute all the values in the equation. We will get u as root of 196, that is 14 meter per second. Now to calculate the time taken by the object to reach the highest point, we will be using the first formula of motion, that is v is equal to u plus at. Put all the values and calculate. We will be getting t as 1.43 seconds. Our second question is, a stone is released from the top of a tower of height 19.6 meter. Calculate its final velocity just before touching the ground. Here, you should know that when we drop an object from a certain height, we don't give it an initial velocity. But because of the acceleration due to gravity, its velocity keeps on increasing as it falls. Therefore, here the initial velocity is 0 meter per second. Distance, that is height of tower, is 19.6 meter. Acceleration due to gravity is 9.8 meter per second square. Now to find the final velocity, that is velocity just before touching the ground, we will be using the third formula of motion, that is v square is equal to u square plus 2as. Substitute all the values in the equation and solve it. After solving, we get the final velocity as 19.6 meter per second. Our third question is, a ball thrown up vertically returns to the thrower after 6 seconds. Find the velocity with which it was thrown up, the maximum height it reaches, and its position after 4 seconds. Now to solve this question, we will divide this motion of the ball into two parts of equal time duration, that is each of 3 seconds. Now first part, that is scene 1, will be motion of ball from ground to the maximum height. Now again you should know that at the highest point the velocity of the ball will become 0. That is, the final velocity in scene 1 will be 0 meter per second, time will be 3 seconds, and acceleration will be minus 9.8 meter per second square, negative as the motion of the ball in this case is against the gravity. Now to find the initial velocity with which the ball was thrown, we will be using the first formula of motion, that is v is equal to u plus at. Substitute all the values and after solving we will get u as 29.4 meter per second. To calculate the maximum height it reaches, we will be using the second formula of motion, which is s is equal to ut plus half at square. Put all the required values and after calculating we get s as 44.1 meter. To get the position of ball after 4 seconds, we will consider the second scene, which is motion of the ball from maximum height to the ground. In this case, the initial velocity will be 0 meter per second. Time will be 4 minus 3, that is 1 second. Acceleration will be 9.8 meter per second square, positive as it is towards the gravity. Now to solve this, we will be using second formula of motion, which is S is equal to ut plus half at square. Put all the required values, and after doing the calculation, we get S as 4.9 meter. Now 4.9 is the distance of the ball from the highest point. Now to get the position of ball from ground, we will be subtracting this distance from the total height. Therefore, the position of ball after 4 seconds from ground will be 44.1 minus 4.9, that is 39.2 meter. Our fourth question is, the volume of a 500-gram sealed packet is 350 centimeter cube. Will the packet float or sink in a liquid whose density is 1.2 gram per centimeter cube? What will be the mass of the liquid displaced by this packet? Now to find whether the packet will float or sink, first we have to calculate the density of packet. Here we know mass of packet is 500 gram, volume of the packet is 350 centimeter cube. Therefore, to calculate the density of packet, we will be using the formula of density, which is mass upon volume. Putting the values, we get density of packet as 1.428 gram per centimeter cube. Now, since the density of packet is more than the density of the liquid, packet will sink. Now, as the packet sinks, the volume of liquid displaced will be equal to volume of the packet. Therefore, volume of liquid displaced is 350 centimeter cube. Density of liquid is 1.2 gram per centimeter cube, which is given in the question. So now using the formula of density, which is mass upon volume, we can calculate mass of liquid displaced by the packet as density into volume, which is 1.2 into 350, which is 420 gram. Our fifth question is, relative density of gold is 19.3. If the density of water is 1000 kg per meter cube, what is the density of gold in SI unit and CGS unit? The givens are, relative density is equal to 19.3, density of water is 1000 kg per meter cube. Now we know relative density is equal to density of substance upon density of water. Now, density of substance, that is of gold, will be equal to relative density into density of water. That is 19.3 into 1000, which is 19,300 kg per meter cube in SI unit. Now to get it in CGS unit, density of gold will be 19,300 divided by 1000, that is the conversion factor, which will give us density of gold as 19.3 gram per centimeter cube. Our sixth question is, the diagram given below shows a body floating in three different liquids A, B and C at different levels. A. In which liquid does the body experience the greatest buoyant force? The answer is, buoyant force is same in each case as the weight of body is same in each case, and buoyant force is equal to the weight of liquid displaced by the immersed part of body, which balances the weight of body. B. Which liquid has the least density? So the answer is, the liquid A has the least density as body immerses the maximum in liquid A. C. Which liquid has the highest density? So the answer is, the liquid C has the highest density as the body immerses the least in liquid C.